Alright guys, just a couple more examples and then you'll get started on your assignment. Let's go to Josh Lim. Help me on 7. What am I going to do here? Awesome. So then when I rewrite this, I'll have a times a plus 5. And then over subtracting, sorry, put that in there. 4 with a plus 3. And that's over our common denominator, a plus 5 and a plus 3. Is that what you're saying, Josh? Mm-hmm. Cool. What do I do next? Okay, so that's going to give me a squared plus 5a minus 4a minus 12 over a plus 5 and a plus 3. Okay, so let's combine like terms. This is going to give a squared plus a minus 12 over a plus 5, a plus 3. Josh, can I do anything from there? We'll always check if we can factor. And I'm going to say I need two numbers that multiply to negative 12 and add to 1. Is there any way we can take factors of negative 12 and add them to a positive 1? There is. What would it be, guys? 4 and negative 3. So that's going to be able to factor here to a plus 4 and a minus 3. But will that simplify with anything that we have over here? No, but it's still good to factor that. Now, the common thing people will do is they'll try to cross these off and put a negative. Are these opposites? Just the numbers are opposites, but the variables need to be opposites too, so we can't cross it out. So we'll just call it good right there. Do you have any questions on that example? Okay, then let's go to Jerson on this next one. Jerson, what am I going to do to start this off? I don't have a common denominator. So what should I do?
Plus t plus 1 on one side.
So over here, you need a t plus 1.
And on the other, t squared.
Okay, cool. Let's write that out. So I'll have 5 times t plus 1 minus 4t squared. And that's all over our t squared times t plus 1. Does that look right? Okay, let's distribute the 5. I'm also going to bring that negative 4t squared to the front. Plus 5t plus 5 over t squared times t plus 1. Alright, let's just check real quick here. Could I factor this? I'm just going to do a quick check just to see if we could. Since I have a leading coefficient of negative 4, I'm going to say I need two numbers that multiply to negative 20 and add to positive 5. So if we're looking at factors of 20, or negative 20, 4 and 5, that won't give us a difference of 5. 10 and 2, 21. Are we able to factor that? Nope, so then what do? Call it good. We're good, okay? Alright. Last type of problem. This is going to be kind of a common problem we're going to see. It's D equals RT. Do you know what that stands for? What does it stand for? Distance is rate times time. A few years ago, there was a really funny video that went viral. It was this guy who asked his wife, if we're driving 80 miles per hour, how long does it take to go 80 miles? Which the answer would be an hour, right? and she spends about 5 or 6 minutes just thinking about it really hard, overthinking it, and comes up with some really funny math there. But anyway, the point is, we're going to remember that distance, how long does it take to go 80 miles per hour if I'm going 80 miles if I'm going 80 miles per hour? This formula could help us out here. So distance equals rate times time. Now I'm going to show you how to do a problem like this. There's one on your homework. You're going to see problems like this like all throughout math, and it's how we use it. So let's actually, Allie, will you read this problem for us?
Jenny was so excited for school that she ran from her house to school at an average rate of 7 miles per hour. After school, she walked home at an average rate of 3 miles per hour. How far away from school does Jenny live? Is the total trip to that?
Okay. Don't you guys run to school? You're like, B-days, I have math. I'm so excited. All right. Well, let's talk about it. So there's two things going on here, right? So when Jenny's running to school and when Jenny's coming home from school. Now, let's go through each variable here. We've got a distance, rate, and time. Is the distance to school the same as the distance home from school? So I'm just going to put that as a variable d, okay? So it's the same distance. We'll use that d. What about rate? How fast is she going when she goes to school? So excited, she's just running at 7 miles an hour. And then afterwards, she's just so sad, so she walks slowly. And what is that? 3. Now, we're not given a lot of information about the time. Obviously, at the time to school, she'll get there faster because she's running faster, and it'll take her longer to get home. But what are we told about the time? If we add them together, it's going to give us 30 minutes or half an hour. So what I'm going to do is I'm going to write this out. I'm going to call this time 1, and this one is time 2. And I'm going to come up with another equation over here. I'm going to say if I do time 1 plus time 2, what do I get? It'll be a half an hour. Now, if we're going to write it as 30 minutes, then I have to change my rates from miles per hour to like miles per minute, and I don't really want to do that. So how could I write half an hour and still leave it in terms of like, let's just do 1/2 or 0.5. Is that okay? Because if I change this from hours to minutes, then I've got to change the other one. So we're going to keep our units the same. So what I'm going to do is I'm going to come up with an equation for each of these. I'm going to solve it for the time, plug it in here, and then solve it from there. So our formula you need to remember is distance equals rate times time. So pretty easy. If she is going to school, then we're going to write that formula is distance equals 7 times time 1. On her way home, it's going to be similar. The distance is going to be equal to 3 times time 2. Now what we're going to do is we're going to solve for time 1, plug that in here. Solve for times 2, put it in here. And then we'll be able to have one variable d we could solve for, and it'll tell us how far she is. Okay? So let's go through. How would I solve for time 1 on this equation here? Good job. It's being times by 7, so we'll just do the opposite. And I'm going to get that time 1 is our distance over 7. So now when I come over to this equation where I saw time 1, I'm going to put distance over 7. Okay, let's do the same thing for time 2. It's being times by 3, so what are we going to do? Divide by 3. And when I do, I'm going to get time 2 is distance over 3. So then I'm going to plug that in over here. So the 2 times, if I add them together, takes a half out. Well, I'm going to represent time 1 as a distance over 7. Time 2 is a distance over 3. And that is going to equal to 0.5. What's your question, Jerson? Which part? Do you know where we got this from? This is time 2.
Yeah.
which we solved to be d over 3. This is time 1, which we solved to be d over 7. If you add the times together, you get half an hour, or adding them together. We've just replaced it.
Okay.
Cool. Alright, can we add these together, guys? No, because what do they need? Common denominator. So what do I need to give the 7? What do I need to give the 3? So what I have here, I'm going to keep going here. If we take 3d over 21 plus 7d over 21, that needs to equal 0.5. Now this is kind of jumping ahead a little bit, because we're going to talk about how to solve these equations in the next section, but we should be able to figure out from here. What's 3d plus 7d? 10d. And I want to solve for d. Well, it's being divided by 21, so what should be the first thing I do? Times it by 21. Okay, so help me out here. What is that 10.5? So with the calculator, will you check me on that? 21 times 0.5. Alright, so 10d is equal to 10.5. So then, I want to solve for d, so what do? Divide by 10. Someone with the calculator, I think that's just going to be 1.05, right? 1.05 what? We just solved for d. So what did d stand for? Distance. So the distance of what? Yeah, from her house to the school is 1.05 what? Miles, right? We're just going to leave it in miles. So she lives about a mile away. So, yeah, she was running at 7 miles per hour on the way there. That's a good pace. She was really excited for that class. It's going to be one of those days. You wait. You're going to have days you're excited for. Eventually. Alright, so guys, now you should be able to do everything with adding and subtracting rational expressions. Gave you the assignment. What I want you to do is come back with questions. Use the remaining time to get started on your homework.